is example 8 on page 259, number 21. We have a uniform plank of length 2 meters and mass 30 kilograms supported by 3 ropes. We want to find the tension in each rope when a 700 Newton person is 0.5 meters from the left end. The first key thing to this problem is the fact that it's not specified where the axis of rotation is placed. Anytime a problem doesn't specify that, you are able to choose where the axis of rotation is, and you want to choose a location where there is an unknown force so that that force does not cause a torque. There are really two options here, either the left end or the right end, and I am going to choose the left end. So my axis of rotation is right here. Now, because this plank is in equilibrium, we don't want it dipping, anything like that, we're going to use both net force and net torque equations to solve for these 3 unknown tensions. And of course, we need a net force equation for the x direction and for the y direction. So in the x direction, we only have 2 forces. We have the x component of T1, and that x component is positive. And we have T3, which is to the left, so it is negative. Because this plank is in equilibrium, this net force is equal to 0, which tells me that T3 equals T1x in magnitude. As for the y direction, we have many more forces in the y direction. Looking at my diagram, I can see that I have T2, and that's positive because it's pointed up. I have T1y, which is positive because that component is also pointed upward. But then I also have the force of gravity. Now, in these problems, you cannot combine the mass of the plank and the person, because that's going to cause a problem when we're looking at the torque equations, since each of those 2 forces act at a different location. So I'm going to keep them separate in here as well. So the force from the man, that's negative because it's downward. And the force from the plank, that's the force of gravity. These are all my forces in the y direction, so adding them all up gives me 0. Now, in each of these equations, I have an unknown. And so I'm going to use my net torque equation to help me figure out one of these unknowns. So looking at the torques that you have on this wooden plank, again, my axis of rotation is at the left-hand side of the plank. So T2 and T3 do not cause a torque. Their radius is 0 since they're acting at the axis of rotation. But T1, that first tension, does cause a torque. And I'm going to look at its direction already. I notice that if I have a plank like that, and I were to pull upward on it as T1 is doing, I would make the plank move counterclockwise. And so tau1, that torque, is positive. And then I also have these 2 forces, the force from the man and the force of gravity on the plank. Both of them act downward, and so they are both going to create clockwise torques. So I'm going to subtract the torque from the man and subtract the torque caused by gravity on the plank. This is the net torque, and so adding them all up, I get 0. I now am going to work with this last equation here. I'm going to write out the equations for each of these. So tau1 we know is T1, that first tension, times r sine theta. Tau m is the force from the man, times r sine theta. And I'm even going to put subscripts on these r's and these thetas because each of them may be different. And then tau g, that's the force, or really the torque caused by gravity, which is the force of gravity times the radius sine theta. All those added together equals 0. Now looking at my direction, I'll notice that for the force from the man, that's going to be a downward force. And my radius points to the right like this. And so the angle between those two is 90 degrees. And the sine of 90 degrees is 1. I'm going to cross that out and put a 1 there. Likewise, we have the exact same thing for the force of gravity. The force is downward, radius is to the right, so the angle is 90 degrees, and the sine of 90 is 1. T1 is my only unknown variable in this equation. I know each of these radii, and I know this angle and those two forces. So I can solve for T1. And when I do that, I get T1 is equal to Fm Rm plus Fg Rg divided by R1 sine theta 1. So I now can go ahead and plug some numbers into this equation, and I will have solved for one of my unknowns. Plugging numbers in, I see that Fm tells me the man is a 700 Newton person. And so 700 newtons is that force, and he's located at 0.5 meters from my axis of rotation. 0.5 meters is R. And then I have the force of gravity. Now notice that's only a magnitude. I didn't put any vector symbols there. So force of gravity is mg, which is 30 kilograms, times 9.8 meters per second squared, times where that force acts. Now we know that the force of gravity always acts at the center of mass. And the center of mass for this plank is right smack dab in the middle. It is a 2 meter long plank, so R is 1 meter. I divide that all by R1 sine theta 1. R1 is the distance from the axis of rotation to T1. That happens to be 2 meters. I multiply 2 meters times the sine of the angle between R and T1. So let's draw that R vector up here. Starting at my axis of rotation, going over all the way, there's my R vector. And when I move it so that that R vector is tail to tail with T1, I can see the angle between them is 40 degrees. So I will plug in 40 degrees over here, plug that all into my calculator, and I find that T1 is 500.94 newtons. That is one of my 3 values I am looking for. Now that I know that value, I can use the force equation to help me come up with the other 2 values. So looking back at these force equations, the one that I'm going to use first is T3 equals T1x. Because since I know the angle for T1, I can find its x and y components. I'm going to do that right now. So T1x and T1y. T1x is just that magnitude of T1 times cosine of 40 degrees. I get 383.75 newtons. That happens to be equal to T3. So that's another one of my unknowns. And T1y is 322 newtons. That's just that magnitude 500.94, this time times the sine of 40 degrees. Now the last thing we're looking for is T2. And I need to use my y equation to find T2. Based on this y equation, I can see that T2 is equal to force of the man plus force of gravity on the plank minus T1y. Force of the man, we already said, was 700 newtons. The plank, it tells us, has a mass of 30 kilograms. meters per second squared, again positive because you notice there's no vector symbols there, minus 322 newtons. Plug all of that into my calculator and I find that T2 is 672 newtons. And so that's my third unknown, and I have finished the problem now.